Hey, if you have any trouble to solve your nonlinear equation using your calculator, it's the video for you to watch. It's probably because of the initial value that you guess and give to your calculator, and that's why you don't get the answer to solve your nonlinear equation. So I recommend you to watch this video. Okay guys, we first want to know uh, what the Newton's method is, because most calculators use this method to find the roots of a nonlinear equation. So assume that we have fx in terms of x, and the curve in red is your equation, and you are interested in finding the root of this red curve. So the concept of Newton's method is like this. For example, you assume a point on the curve, and then you draw a tangent line to this point on the curve, something like that. And then it intersects with the x-axis. Then you draw another tangent line on the red curve from this new x. And as you see, we approach the root. And if you continue the iteration, you get closer to the root of the red curve, and finally you find the root of the nonlinear equation after a few iterations. That's the fundamental of Newton's method. So next I'm gonna show you how to derive the relationship for Newton's method, which we need to consider and use it in our calculator. Okay, this is the same curve that we talked about, and here I already drew some lines to show you how the x approaches the root. The root here is x3, and we start with x null or x0. So as you see, the first tangent on the curve intersects the x-axis at point x1. So if we now consider this triangle, let me just highlight that triangle for you. If we just consider this triangle, we know that the slope of this line, the tangent line on the red curve, is tangent of alpha, which is equal to f prime x null. So the differentiation of fx. So we know that a slope, we know x null, x0, and we are interested in finding x1. So let me just use the basics of trigonometry to derive the Newton's relationship. Okay. Tangent alpha is equal to this side, fx null, over x0 minus x1. And we are interested in finding x1. And that tangent of alpha is equal to f prime x null. So if we just rearrange the terms, we get x null minus x1 equals fx null over f prime x null. And x1 is equal to x null minus f x null over f prime x null. So yeah, this is the equation. This is the Newton's equation. So we have x null, f x null, and f prime x null. All of these are known, and we then obtain x1. So the next point is determined. So if we continue the iteration, we obtain x2 with the same approach. We have this triangle, the green one. With the same approach, we obtain x2, and then we continue iteration and we obtain x3, which is our root. So that's the basics of Newton's method, as simple as that. Some references offer that we may consider Taylor's series to derive Newton's method, but I believe this simple illustration is more is simpler and more comprehensive to understand. So I just decided to show you this approach. In the next video, I'm going to show you how to use this simple equation that I obtained in your calculator to find the root of a nonlinear equation. But as I mentioned in the beginning of this video, the initial guess, the value that you initially guess in your calculator is very important. And with examples, I show you why this is important. So if you have any questions, please leave a comment down below and I will get back to you as soon as I can. Also, if this video helped you in any way, please hit the like button and subscribe if you enjoy our content and would like to see more. Okay, see you in the next video.